I've been waiting weeks to do this video, and I know that a lot of you have been too. Hello all you crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about making games. On the Raspberry Pi. So about a month ago, the GameMaker Studio 2.3.1 update came out, and added a couple cool things, some of which I will almost certainly be talking about in due time. But the one that we're interested in today is the ability to build games for ARM devices. So for those of you who don't know, ARM is a type of CPU architecture, which is commonly found in small devices such as mobile devices and embedded systems and that sort of thing.
Hey.
The CPU architecture that pretty much all desktop computer CPUs use, such as your AMD Ryzen whatevers and your Intel whatevers, is pretty much all x86, which is what most desktop computer software is built on. But for a long time, honestly probably since the Raspberry Pi initially came out 10 years ago, there's been a lot of interest in running GameMaker games on a Raspberry Pi. So for those of you who don't know, the Raspberry Pi is not, as the name implies, a thing that you might find in a kitchen, but it is a $40 single board computer that you can install Linux on and just use as a general purpose computer, as maybe a miniature file server, a smart device controller. Quite a lot of people use them for things like arcade cabinets, as you can imagine. So let's talk about how to build games for those using GameMaker. So you are going to need a few things to get started. One, obviously, you're going to need the Raspberry Pi itself. I strongly recommend if you're going to do this using a Raspberry Pi 4, it'll technically work on older versions very poorly. And by that, I mean an empty project will run at about 30 frames per second. It's not worth it, just use a Raspberry Pi 4. You are also going to want to have it set up and connected to your network and everything. Specifically, you're going to want to have SSH enabled so that GameMaker can talk to the Raspberry Pi when it tries to build a game on it. Rather than going through all of that right now, I've made a separate video on how to set up a Raspberry Pi. There should be a link to it in the card popping out of the screen right now, down in the video description, probably in the end screen. If you are familiar with how Raspberry Pis work, and you have set one up before, and you have used them before, and especially if you have used Linux before, you probably already know everything that's in that video. Otherwise, if this is your first time doing this kind of thing, you might want to pause this video and go check that out first. It's about 20 minutes long and much easier than it used to be in the past. You will also specifically need to be using GameMaker Studio version 2.3.1 or later. If you're watching this video far in the future after November 2020, then that's most likely just the regular stable version of GameMaker. If you don't know what version you're using, look in the upper right of your screen to where it says runtime. If it says version 2.3.1 or something more recent than that, then you're good. If it shows a numbering system that's different from that, then you're already using the beta, and I'm going to assume that you're a power user who already knows what version you're using. Failing those two things, you will need to use the beta version of GameMaker. To get that, all you have to do is go to yoyogames.com, log into your account, go to the GameMaker downloads page, and there should be a tab next to the regular GameMaker Studio 2 for the beta, which you can click on, download the installer, and set it up independently of your regular GameMaker installation. So before I do anything else, let's have a quick look at this base project that I have open here. This is kind of my 2D demo project that I use for a lot of things. It's got some audio playing, it's got some sprites running around on the screen, it's got some interaction if you hit the spacebar in front of these guys. It's not very fancy, but it works, and you can see that it is indeed functioning the way it's intended to. So, first we're going to go over and look at the Raspberry Pi. I am going to minimize all that and open up my HDMI Elgato capture program so that I can see what's going on and record that screen. It would have been nice if I'd turned this on before I started recording, so I don't have to wait for it to start. Okay, so once you're on your Raspberry Pi desktop, there's a few things you'll need to do to set this up for GameMaker. Open the terminal. One, you've probably already done this, but it never hurts to have an up-to-date operating system, so sudo apt update, which will refresh the list of anything that needs to be updated on your Raspberry Pi. All packages are up to date, that's fine. If they were not, sudo apt upgrade would actually install said updates, should there be any. Next, there's a few libraries you'll want to have installed. These are development tools and similar things. This is the full list. You can install them all one by one with the apt command. You can install them all in one shot by stringing them all together into a single apt command like this. If you do not feel like typing that all into your terminal, I don't blame you. And I'll have the commands typed out in the video description so you can copy and paste it either into an SSH client on Windows such as Extra Putty, or just by opening the video on the Raspberry Pi itself and copying and pasting it from there. Depending on what version of the operating system you have, some of these may already be installed. I think these days libopenal is installed by default, but it never hurts to be sure. Myself, I'm just going to type them all out at once and hope I don't make a mistake with my loudest keyboard on the entire planet. Is that it? There is a single stray character on the end of zlibg dev over here. So now I can hit enter. This is going to go through all of the things that I may try to install and or update. Do I want to continue? 304 additional megabytes of space will be used. Yes. That's going to take a moment. Okay, there we go. Everything looks okay. The last thing you'll want to do is get the IP address of your Raspberry Pi. If you recently watched the Raspberry Pi setup video I made, you may remember how to do this. Otherwise, ifconfig to show some information about the network adapters on the Raspberry Pi. The one that we were interested in right now, since my Raspberry Pi is connected to the network via Wi-Fi, is the WLAN 0 iNet address. This is the IPv4 local address, 192.168.1.8 in this case. I think when I made that video, it was 192.168.1.26 or something. I guess the router decided to give me a different address this time. Anyway, write that down, or just remember it because it's not too long. And I am going to switch my computer monitor inputs back to Windows over here. So now that we are back in the land of desktop computing, if you go back to your GameMaker IDE that has your project open that you're looking at, go up here to the upper right of the screen, and as long as you have the desktop version of the game engine installed and running, you will see Windows, Mac OS, and Ubuntu as your platform options. Click Ubuntu. There's a couple other columns here if you've never clicked on this target platform button up here before. The one that we're interested in right now is the one that says device. Click on that. That'll open the device editor. So a little bit of background on this. Whenever you build a game or computer software in general for a kind of hardware other than the one that you're using to develop said game or computer software, generally speaking, you'll need a device of that type on hand to connect to remotely so that you can compile your code and build your game for.
Hey.
Obviously, as most of you know, there are some fundamental differences between things like Mac OS and Windows that will prevent executable files of one from working on the other. This gets a little bit muddier when you're using a game engine such as GameMaker, and you essentially have a runner for your game that is pretty much the same every time for every game that you make, and all that it's really doing is looking for a collection of data files and executing them. How the GameMaker virtual machine works is definitely a subject for another day. Anyway, click Add New Device. You have a display name. Just give it a name so that you know what it is and can identify it. Raspberry Pi should suffice in my case. Host name is the IP address. In my case, 192.168.1.8. In your case, it'll be whatever you saw when you hit the if command on the terminal. Username is whatever your default username on the Raspberry Pi is. I just left it as default, which is Pi, and the password is whatever your password is. I think in this installation it is just the default password because this is a different SD card than the one that I made the video with, which went up alongside this one. The install folder is the location on the Raspberry Pi which GameMaker will be working out of. The default is just the home directory and a folder called GameMaker Studio 2.
Hey.
That's fine by me. That's probably fine for most people. If you, for some reason, want to have GameMaker work out of another directory, just type it in there. Anyway, when you hit test connection, you'll see if GameMaker is able to connect to the Raspberry Pi. In my case, it is, and we can hit OK. Alright, and now the moment of truth. I should probably have this open next to me so that I can ensure that it is working properly. Let's run the game, and if all has gone according to plan, this should just work. And on the Raspberry Pi, in a minute or so, you should see the game pop up. And the game is now running on a Raspberry Pi. Alright, so the graphics are all there, the audio's there. Future self, please remember to turn the volume up a little bit because I have the volume of the capture program muted, so I can't actually hear it, but rest assured the audio is playing. You can run around, you can hit the button that'll play that little animation, you can hit the spacebar to talk to these guys, and everything works as it did before. So a few things you may notice. One, probably the most obvious, is that texture filtering is turned on, texture scaling, whatever you want to call it. You can see the sprites as they are scaled up are a little bit fuzzy. For example, in the upper left of the screen where those heart things are, you can see there's a little bit of blurring going on around the sides. That is simply one of the default graphic settings for the Linux export of GameMaker. If you go to Game Options Ubuntu and go to Graphics, you have a couple options: Start and Full Screen, Allow Full Screen Switching. These are, for the most part, all the settings that are there for the Windows. The one of interest here is Interpolate Colors Between Pixels. We can turn that off. I guess on Windows I have that turned off, or it's turned off by default or something, because that is not something that happens when I run the game on Windows. If I were to run it again, they would look much sharper. There would be less blurring. There would be no blurring around the pixels as they're scaled up. There we go. That looks much better. That's just something that people may want to be aware of. Another thing that a lot of people will probably find concerning inevitably is performance. I cannot say this enough. The Raspberry Pi 4 is a 1 and change gigahertz quad-core ARM CPU, which is by all accounts much, much better than the Raspberry Pi 3 and other past iterations of the Raspberry Pi, but it is still nowhere near what you will find in even inside a low-end desktop computer. If you want to see how it's performing, if you want to get a general idea of how your game is performing, you can use the show debug overlay function, and that will draw a little ribbon on the top of the screen, which will show things like the frame rate and what parts of your game are using what parts of your game are running the slowest. So now if you run the game, this is pretty much an empty project. So right now it's going to be mostly fine. It looks like this is running at about 500-ish FPS, I think is what that says, which is decent. That means it takes each frame about-ish 2 milliseconds to process start to finish. Whereas if you want to have your game running at 30 frames per second, you will need to have all of the object step events and all of the objects draw events and anything else that might happen. You'll need to have that run in 33 milliseconds or less. And if you want to have your game running at 60 frames per second, that's going to need to fit inside 16 milliseconds or less. So for this demo project, performance is certainly okay. If you're making arcade games like Pong or Centipede or whatever and you're running those on your Raspberry Pi, you'll almost certainly be okay. For more graphically involved things, you're going to want to be a little bit more frugal with how you draw stuff. In the past, in tests I've done with this thing, I've noticed that this thing's graphics unit is, let's say, not very strong. I feel like even things like integrated graphics units that you might find on a laptop CPU are stronger than this and can draw more things at once. Certainly do be careful with things like complicated shaders, as those can have a noticeable performance hit. Optimizing games is an entire can of worms that I want to do other videos on someday that is not today. Anyway, let's close that. I am going to get rid of this debug overlay for now. Once you're finished, once you're done making your game, building your game should work just the same as it always does. If you click the build button, wherever that happens to be, and it should pop up a file finder and allow you to save a file. If you do that, it'll go through the steps of building your game. It'll do all the stuff on the Raspberry Pi that it has to, and then once it's finished, it should send the file back to Windows and save it on your computer. And here you have it, Raspberry Pi demo.zip. And if I open that, you will see that instead of the usual game executable and data.win data file and a couple of configuration files, you will see that instead you simply have a file called Raspberry Pi demo. This is the executable.
Hey.
This is the Linux version of the executable, and you have an assets folder which contains game.unx as opposed to game.win. It contains a game icons file and options, configuration, settings, ini, and the background music file. That's what the file system looks like for Linux GameMaker games, which is mildly interesting. Okay, some closing notes. So as I've said several times in this video, this is still in beta, and as many things have when they're still in beta, there is the possibility for unexpected bugs to be involved. I have not found any game-breaking bugs on the Raspberry Pi's export module, although with that said, I haven't tried anything unusually ambitious either. If you do find anything unexpected happening, which does not happen on Windows, by all means submit a bug request to Yo-Yo Games. I'm sure they'll want to hear about this and patch it out before it goes on the stable release. If you're watching this video far in the future, hopefully that will no longer be the case. In fact, speaking of bugs, if anyone's wondering why this took like 2 weeks longer for me to make than anyone really wanted it to, there was actually a bug, which caused some files to be saved with the wrong file names and the wrong locations when you hit the run button, which you had to work around by manually renaming the files and running the executable yourself, which was a huge pain in the neck, which I didn't really want to put in a video because it was kind of long and stupid, and I was hoping that the update would just come out and fix it sooner or later anyway. So that's that story. What else? As with any time when you're trying to run a GameMaker game on something that isn't Windows, any Windows extension which has been compiled into a DLL will not work. DLLs are essentially like half executables that contain executable code, but they cannot execute themselves. They're essentially libraries for other programs to use. Those will not work on the Raspberry Pi. If you have access to the source code for the extension, you may be able to compile it yourself, specifically for the Raspberry Pi, into a shared object and use that as your extension. But otherwise, DLLs won't work, as well as some other Windows-specific functions that GameMaker offers. Things that have to do specifically with the operating system. Let's see, before I go, I imagine at least a couple people will be interested in seeing some of the limits of the Raspberry Pi. The tower defense game that I'm making in a series on Wednesdays on this channel is somewhat more graphically complex than this little demo with a little duck and some dogs. So for the purposes of demonstration, I will be loading that up, and I will run that on the Raspberry Pi, and you can see how that's going to perform. I will say that game is not optimized at all yet. There are a lot of things that I can do and undoubtedly will do in the future that will make it run more smoothly both on Windows and on the Raspberry Pi. Okay, so here we go. This is what I call Bombardier. This is the tower defense game. First, I will run it on Windows so that you can see what it looks like, and then I will swap the target device to the Raspberry Pi, and we can build it on there. This may take a little longer, considering that there's 1 more code, 2 more assets, and 3 more shaders to compile. Alright, here we go. This is tower defense. This is going to be the state of the project as of next Wednesday. I have recorded 1 video, which has yet to go up. For that video, you see you have a 3D scene, you have some towers, and you have some really, really bad-looking programmer or ants, which are coming out and following the path. All right, that's cool. That's what it looks like. So let me go switch the target to Ubuntu on the Raspberry Pi as my target device, and let's do this. This will take a moment. Okay, so that took a little while to start. 1, because I had to load a lot of files, and 2, we are running this at 4 frames per second. I told you it wasn't very well optimized, at least not yet. Again, this isn't all doom and gloom for the performance abilities of the Raspberry Pi. There are a lot of things that could be done to optimize this. There are a lot of shader things that I could just take out that don't need to be there, that may or may not be slowing things down. Again, optimization, particularly 3D optimization, is a subject for another video. I see the frame rate is sort of consistently going up to like 18/20, up from 4 or 5 that it was when it first started. Anyway, lastly, thinking of performance issues, if you really want to see what this looks like running on a Raspberry Pi 3, I posted a screenshot of what that looked like on various social media a while ago. Let's just say that it was running about as well as the tower defense game was, despite being a basically empty project. I'll show a video on screen now of how that was going. There were some things that could have been done to make it run better, but honestly, if you have pretty much any gameplay or drawing or anything at all going on in there, the frame rate is beyond saving. Use a Raspberry Pi 4. Anyway, that's it. If you want to code to this demo project, there will be a link to that repository on GitHub in the video description. There's no code that I wrote specifically for Raspberry Pi or anything today, but if you want to mess around with that base project, go ahead. I have a Patreon, so if you want to contribute towards these videos being made, there's links to that in all the usual places. I try to post about 2 of these videos a week. 1 of these tutorial things and 1 of those tower defense things that you saw a little bit of not too long ago. It runs much better on Windows, I promise. In particular, if you like shaders and graphics programming, stick around, because I'm going to be doing a lot of that for the rest of the year, I think. Anyway, I hope you all found that useful. Go ahead and make yourself a nice arcade cabinet out of a Raspberry Pi using games that you made yourself in GameMaker, and I will see you all later. Special thanks to Edward Holt, Indie Punch, Jason, and Zenith for supporting these videos. If you want your name in the credits or to hear yourself shouted out at the end, head over to the Patreon page in the video description to join the fun.